Welcome to the Abyss, where beauty hides teeth sharper than any sharks. We're diving into the 13 lagoons on this planet where survival isn't just unlikely, it's a joke nature tells right before she laughs last. These aren't your postcard turquoise pools for Instagram dips. These are places where water itself turns traitor, acidic enough to melt flesh, boiling like forgotten kettles, choked with invisible gases that steal your breath without warning, or home to creatures that make horror movies look tame. If you value clean water in your pool and the luxury of swimming without risking dissolution, instant burns, or turning into a calcified statue, support this series with a like. Drop a comment. Which lagoon from this list would you absolutely not last an hour in? Your thoughts fuel these deep dives into the planet's darkest, watery corners. Lagoon number 1, Laguna Caliente, the acid bath of Poás Volcano, Costa Rica. Picture this, a perfect crater high in the Cordillera Central, ringed by misty green slopes that look ripped from a tropical dream. The water gleams an unearthly turquoise so vivid it hurts the eyes, like someone poured antifreeze into a volcanic bowl and stirred. From afar or through a tourist zoom lens, it promises refreshment after the sweaty hike up. Up close, the joke lands hard. This isn't water. This is nature's industrial solvent, one of the most acidic natural bodies anywhere on Earth. The paradox hits first. Laguna Caliente sits in the caldera of an active volcano Poás, whose eruptions have sculpted the landscape for centuries. The crater lake should be a geothermal wonder. Warm mineral springs, bubbling vents, colors born from dissolved metals and sulfur. In a kinder world, it would draw spa-goers chasing therapeutic soaks. Instead, the volcano's breath turns paradise toxic. Magma far below leaks gases, sulfur dioxide, hydrogen chloride, hydrogen fluoride, carbon dioxide, up through fissures. These dissolve relentlessly into the relatively shallow waters, brewing a cocktail with acidity rivaling battery acid, or worse. The pH plunges to levels so low that ordinary measurements strain to register them accurately. We're talking values scraping near 0 on the scale, where neutral sits at 7, and household vinegar feels tame at around 3. The collapse came gradually, then catastrophically in bursts. Poás isn't a dormant giant. It's alive, grumbling. Eruptions in recent decades sent ash plumes skyward, phreatic blasts, steam-driven explosions, hurling rocks, and surges of fresh magmatic input spiking the acid production. The lake level fluctuates wildly. Sometimes it drains through subsurface cracks, exposing yellow sulfur flats that look like alien cheese. Other times it refills, concentrating the toxins even more. Scientists monitor it obsessively because one major shift, an earthquake, a fresh gas pulse, could trigger a limnic release or superheated surge. But the real killer is the quiet chemistry. Touch the water, your skin blisters instantly. Inhale the fumes wafting off the surface. Lungs burn like you've swallowed fire. Sulfur gases mix with the air to create that classic rotten egg stench, but laced with corrosives that eat at mucous membranes. Now imagine a day trying to survive here. Forget swimming, that's suicide in minutes. Even standing on the rim requires a gas mask on bad days. The national park often closes access when emissions spike. Local guides tell stories of foolhardy adventurers who ignored warnings. One guy dipped a finger for a dare, ended up with chemical burns needing weeks of treatment. Wildlife? Almost nothing survives in the water itself. A few extremophile bacteria and algae cling to the edges, turning the shallows sickly green or orange. But fish, frogs, birds, gone. The surrounding cloud forest teems with life, but the crater acts like a dead zone boundary. Birds avoid flying over it during heavy fume days. Insects drop mid-air. The few hardy plants on the crater walls are stunted, leaves curled from acid rain fallout. The irony bites deepest when you consider the sulfur miners of old. Before strict protections, people descended into similar craters elsewhere to harvest the yellow deposits. Here, modern monitoring stations hum with equipment. Scientists in hazmat gear collect samples like crime scene investigators. Yet the lake remains indifferent, quietly concentrating its venom. One wrong wind shift and the fumes roll downhill, reminding everyone that beauty here is a warning label. Philosophically, Laguna Caliente forces the question, why does nature create such lethal elegance? Is it random chemistry, or a reminder that paradise and poison often share the same address? The human spirit marvels at the color, the resilience of extremophiles thriving in hell broth, yet recoils at the cost of curiosity. Statistics say few die here directly. Warnings work. But every year, someone tempts fate and learns the hard way. The real tragedy isn't the body count. It's the indifference of a system that doesn't care if you're impressed or incinerated. From this steaming turquoise death trap in Costa Rica, we move to another volcanic jewel. One where the water doesn't just burn on contact. It simmers at temperatures that cook you alive while you watch the bubbles rise. Lagoon number 2, Kawah Ijen Crater Lake, the blue flame inferno of East Java, Indonesia. Imagine a volcanic bowl carved into the side of a mountain, where the water glows an impossible turquoise, so electric it looks photoshopped even in real life. At night, ethereal blue flames dance across the shores like something out of a fever dream, silent, hypnotic, otherworldly. Sulfur miners haul 100-pound loads up treacherous paths in the pre-dawn dark, their faces masked against fumes that could kill slower than the lake itself. From a distance, Kawah Ijen promises adventure tourism gold, rare geological spectacle, Instagram immortality. Step closer, and the mirage shatters. This isn't a lagoon for dipping toes. It's one of the planet's most acidic natural bodies of water. A cauldron where volcanic gases brew sulfuric and hydrochloric acid in concentrations that strip metal, dissolve flesh, and turn breath into fire. The paradox unfolds immediately. Kawah Ijen nestles in the caldera of an active stratovolcano on Java, part of the Ring of Fire's relentless churn. The lake should be a geothermal postcard, mineral-rich, vividly colored from dissolved iron, copper, and other metals suspended like paint in solution. In theory, it could host unique extremophile life, or draw eco-tourists marveling at nature's artistry. Instead, the volcano's ongoing activity poisons the paradise. Deep magma chambers release constant streams of sulfur dioxide, hydrogen chloride, hydrogen sulfide, gases that bubble up through fumaroles and vents, dissolving into the water to form hyperacidic soup. The pH hovers below 0.3 in places, lower than almost any other natural lake measured, making household drain cleaners seem mild by comparison. Sulfuric acid dominates, eating through rock, equipment, even the miners' tools over time. The water's temperature swings from merely warm to scalding near vents, and the sheer volume, largest highly acidic crater lake known, concentrates the toxicity to lethal extremes. The anatomy of this danger builds over eons, but spikes with every eruption cycle. Ijen's last major eruptive phase centuries ago left the caldera, but fumarolic activity never stopped. Gases percolate up constantly, reacting in the water to precipitate sulfur on the lake bed and shores. Bright yellow deposits miners harvest by hand. The process is brutal. Workers descend pre-dawn into the crater, pipe sulfur dioxide vents to burn off excess gas, creating those famous blue flames when ignited. Sulfur combusts at high heat into that eerie cobalt glow. Then chisel solidified sulfur into chunks. They shoulder baskets up steep, slippery paths, often coughing blood from chronic exposure. The lake itself rarely erupts violently like Nios, but phreatic bursts happen, steam explosions when groundwater hits hot rock, hurling acidic spray that burns skin on contact. Inhalation risks are constant. Hydrogen sulfide at low levels smells like rotten eggs, but higher concentrations numb the sense of smell, letting victims breathe poison unaware until collapse. A few tourists have fallen in over the years, bodies dissolve fast, leaving little trace beyond warnings etched deeper into local memory. Surviving a day here feels like tempting every rule of biology. Forget swimming. Immersion for seconds means third-degree chemical burns, tissue necrosis as acid denatures proteins. Even standing on the crater rim requires gas masks on fume-heavy days. Sulfur dioxide irritates lungs like tear gas mixed with fire. Miners last years, but many retire early, with scarred lungs, eroded teeth, chronic respiratory disease. Wildlife fares worse. Almost nothing lives in the lake proper. A few acid-tolerant microbes and algae tint the edges sickly green or orange. But fish, amphibians, insects, vanished. Birds skirt the crater during bad gas days. Mammals avoid it entirely. The surrounding rainforest thrives, but the crater rim marks a stark boundary. Life stops where acidity begins. Sulfur miners represent the only survivors, enduring for wages that seem decent locally, yet by little health. They trek 3 kilometers post-crater with loads paid by weight, fueling a global sulfur market, while their bodies pay the real price. The irony cuts sharpest at night. Those blue flames, sulfur burning at temperatures hot enough to glow, look magical, like hell's own aurora. Tour groups flock for the spectacle, hiking in darkness to witness what feels supernatural. Yet the same flames signal deadly gas release. One shift in wind, and toxic clouds roll across paths. Scientists monitor obsessively. Degassing pipes installed years ago pipe some gases away, but the lake remains volatile. A major seismic event or fresh magmatic pulse could spike acidity or trigger a surge. Meanwhile, the turquoise water sits indifferent, beautiful enough to lure the curious, lethal enough to punish them. Philosophically, Kawa Ijin asks why nature pairs such stunning visuals with raw hostility. The blue flames mesmerize, the color enchants, yet both stem from the same chemistry that kills. Extremophiles prove life adapts to hellish conditions. Miners show human tenacity borders on madness. Statistics record few direct deaths from the lake itself, warnings and access controls help, but chronic exposure claims lives slowly, quietly. The true tragedy lies in the indifference, a system that creates wonder and suffering in equal measure, caring nothing for spectators or sufferers alike. From Indonesia's acid-lit nightmare, we shift to a different kind of killer. One where the water looks calm, even inviting, but hides a silent, explosive potential that once wiped out villages in their sleep. Lagoon number 3, Lake Nyos, the silent killer of northwest Cameroon. Envision a deep, serene crater nestled in the highlands of Cameroon, ringed by lush green hills that roll like velvet under the African sun. The water lies mirror calm, dark and inviting, reflecting the sky in perfect stillness. Local legends once called it a peaceful place, a natural reservoir fed by rains and hidden springs. From the shore, it whispers promises of fishing, bathing, quiet reflection after a long day in the fields. Yet this tranquility masks the deadliest joke nature has played in modern times. Lake Nyos isn't merely a lake. It's a loaded gun of carbon dioxide, primed by volcanic depths and ready to erupt without warning. Without fire or lava, just suffocating silence that claims lives by the thousands in their sleep. The paradox strikes like a cold wave. Nyos occupies the Mar, a volcanic explosion crater, formed thousands of years ago when magma met groundwater in a violent phreatomagmatic blast. In a gentler world, it would be a pristine highland reservoir, supporting villages with water, fish, and beauty amid Cameroon's volcanic line known as the Cameroon Volcanic Line. The lake sits atop old magma chambers that leak carbon dioxide slowly, dissolving it under pressure at depths reaching hundreds of feet. The water stratifies. Cold, dense bottom layers trap massive volumes of CO2, like a bottle of soda under cap. In theory, gradual release through diffusion keeps things stable. But stability here is illusion. The gas builds relentlessly, year after year, until saturation hits critical mass. One trigger, a landslide, earthquake tremor, heavy rain stirring the layers, and the lake overturns in a limnic eruption, belching a dense cloud heavier than air that rolls downhill like fog from hell. The anatomy of catastrophe unfolded on a quiet night in late summer 1986. Around 10 o'clock, villagers near the lake heard odd rumbling, like distant thunder or bubbling from the depths. Then white mist rose, hugging the ground, flowing north into valleys at speeds up to 30 miles per hour. Carbon dioxide, odorless and colorless in high concentration, displaced oxygen completely. People in Nios, Cha, Subum, Kam, villages dotting the lowlands, collapsed where they stood, sat, or slept. Families died in beds, children beside parents, livestock in pens. The cloud, thick as 50 feet in places, traveled over 15 miles before dissipating. 1,746 humans perished, along with 3,500 cattle. Survivors described waking to silence. No birds, no cries, just bodies everywhere, faces peaceful as if still dreaming. The gas caused rapid asphyxiation, dizziness, blackout, respiratory arrest. No burns, no wounds, just the quiet theft of breath. Surviving a day around Nios post-disaster feels like walking a minefield of memory and lingering risk. The lake refilled with gas over time, though engineers installed degassing pipes in the 90s and beyond. Tall pipes, siphoning deep water to release CO2 safely at the surface, like bleeding a pressure cooker. Yet the threat persists. Saturation remains high enough that another overturn could happen if pipes fail or a seismic event disrupts stratification. Locals resettled nearby live with warnings. Avoid low-lying areas during still nights. Recognize the rare Mazuku, evil wind, pockets, where CO2 pools naturally in depressions. Wildlife suffered too. Fish died off en masse during the event. Birds vanished from the skies above the valleys. Vegetation stayed eerily green. Plants don't breathe oxygen the same way, but the ecosystem bears scars. Frogs and insects return slowly, but the lake itself hosts almost no macroscopic life in the deep layers. It's a stratified tomb of dissolved gas. The irony slices deepest in the aftermath. What looks like paradise from afar, cool highlands, fertile soil nearby, became synonymous with invisible death. Scientists flock here as a natural lab for limnic eruption study, measuring saturation levels, modeling triggers. Tourists once came for the views. Now, access is restricted, signs warn of sudden gas releases. The blue flames and acid colors of other craters draw crowds for spectacle, but Nios draws somber researchers and the occasional documentary crew. The water remains deceptively clear in shallows, tempting a dip on hot days. Yet one deep breath near a gas seep could drop you. Engineers monitor tirelessly, but nature doesn't sign contracts. Another event remains possible, perhaps smaller, perhaps catastrophic. Philosophically, Lake Nios confronts us with nature's most insidious weapon: silence. No roar of eruption, no flash of lightning, just a heavy blanket that smothers without malice. Human resilience shows in the rebuilding. Degassing tech saved lives, communities adapted. Yet the lake reminds us that some dangers don't announce themselves. Statistics capture the body count from that one night, but miss the ongoing anxiety, the ghost villages, the what-ifs that haunt survivors. The real lesson isn't in the death toll. It's in how beauty can conceal apocalypse, how a calm surface hides pressure that could erase generations without a sound. From Cameroon's suffocating crater, we drift to another African giant, one where methane and carbon dioxide lurk in volumes that could dwarf Nios, threatening millions if the balance ever tips. Lagoon number 4, Lake Kivu, the ticking time bomb of the African Rift, Rwanda/Democratic Republic of Congo. Visualize the largest freshwater body in this stretch of the Great Rift Valley, a vast, deep expanse stretching over 50 miles long and 30 miles wide at its broadest, cradled between steep green hills and volcanic peaks. The surface shimmers under equatorial sun, dotted with fishing boats and the occasional hippo breaking the calm. Shores bustle with life, markets in Goma, villages hugging the waterline, ferries crossing between Rwanda and the Democratic Republic of Congo. From the vantage of a hillside, Lake Kivu looks like a serene inland sea, a lifeline for fishing communities, transport, and even emerging energy dreams. Yet beneath that placid mirror lies one of the planet's most terrifying accumulations. Cubic miles of dissolved carbon dioxide and methane, pressurized by depth and salinity stratification, waiting for the slightest disturbance to unleash a catastrophe that could dwarf anything seen before. The paradox unfolds on a scale that defies easy comprehension. Kivu sits in a tectonically active zone, fed by hydrothermal vents that pump volcanic gases into its depths. In a more forgiving geology, those gases might dissipate harmlessly or fuel hot springs for tourism. Instead, the lake's unique meromictic structure, layers of denser, saltier water below trapping lighter surface layers, creates a natural pressure cooker. Carbon dioxide from magma seeps in steadily, dissolving under hundreds of feet of water pressure. Bacteria in the anoxic depths convert some of it to methane, adding another explosive ingredient laced with toxic hydrogen sulfide. Estimates place the stored gas at hundreds of cubic kilometers, enough carbon dioxide equivalent to several % of annual global emissions if released at once, plus vast methane volumes that amplify the greenhouse punch. The water stays stratified for centuries or millennia, but saturation creeps upward. Current levels hover well below full, but high enough that experts warn of spontaneous overturn if the balance tips to 100%, or faster if triggered externally. The anatomy of potential disaster draws chilling parallels to Nios, but on steroids. A limnic eruption here wouldn't just bubble up quietly. It could involve overturn of stratified layers, perhaps sparked by an earthquake, common in the rift. A major lava inflow from nearby Nyiragongo volcano, which erupted dramatically not long ago. Or even heavy rains destabilizing the chemoclines. When the deep waters rise rapidly, gases exsolve in a chain reaction. Millions of tons venting to the surface, forming dense clouds heavier than air that hug the ground and flow downhill into populated valleys. Unlike Nios's relatively contained valley, Kivu's catchment sprawls across densely inhabited shores. 2 million people or more live in the immediate basin, with cities like Goma pressing right to the water's edge. The gas mix isn't pure carbon dioxide. Methane adds flammability and asphyxiation potency. Hydrogen sulfide brings rotten egg toxicity that irritates eyes and lungs before killing. A full release could create fog-like blankets lingering days or weeks, suffocating everything in low-lying zones, people, livestock, crops, while the atmospheric pulse accelerates climate chaos far beyond local tragedy. Surviving a hypothetical day in the eruption scenario defies imagination, but even in calm times, the lake carries quiet menace. Fishermen venture out daily, nets cast into shallows teeming with fish adapted to the odd chemistry. Yet deeper waters remain barren, anoxic tombs where only microbes thrive. Shoreline communities draw water cautiously, aware of occasional gas seeps in sheltered bays that create dead zones where birds drop mid-flight. Extraction projects add another layer of tension. Companies pipe methane from depth for power generation, aiming to degas safely while producing electricity for the region. Proponents argue it mitigates risk by slowly bleeding pressure. Critics fear pipe failures or improper design could trigger premature overturn. Engineers monitor saturation obsessively. Sensors track temperature, gas concentrations, stratification stability. But the lake answers to no authority. Wildlife persists on the surface. Hippos wallow, birds skim, fish schools dart. But the depths remain a biological void, a reminder that beauty floats atop lethal potential. The irony cuts deepest in daily life. Kivu sustains communities, fish protein, transport routes, hopes for energy independence, while harboring apocalypse. Goma's streets hum with markets, children play near the shore, ferries ply routes oblivious to the countdown below. Scientists debate timelines. Some say saturation rises slowly, giving decades for safety gassing. Others warn that volcanic activity or seismic shifts could accelerate everything overnight. Nyiragongo's lava flows have threatened the lake before, and one major intrusion could heat deep layers enough to destabilize everything. Meanwhile, the turquoise blue water laps innocently, tempting swimmers on hot afternoons, though wiser locals stick to shallows and avoid mysterious bubbling spots. Philosophically, Lake Kivu embodies nature's cruelest gamble, a resource hidden as both gift and curse. Methane promises power in a region starved for it, yet tapping it risks awakening the monster. Human ingenuity installs pipes, runs models, debates ethics, yet the lake remains indifferent. Its gases accumulating like interest on a debt no one asked for. Statistics project millions at risk if eruption hits, but miss the subtler toll. Constant low-level anxiety, the what-ifs that shadow every lakeside home. The paradox of depending on the very thing that could erase you. Resilience shows in ongoing life. People fish, trade, build, yet the water's calm surface mocks every warning sign. From the rift's explosive secret, we turn to a Caribbean cauldron, one where temperatures climb so high the lake literally steams, a perpetual boil that cooks anything foolish enough to approach too closely. Lagoon number 5, Boiling Lake, the perpetual cauldron of Morne-Trois Pitons, Dominica. Picture a steaming gray-blue eye set deep in the rugged heart of Dominica's rainforest-clad mountains, ringed by sheer crater walls draped in mist and lush green. The water churns and roils constantly, bubbles bursting across its surface like a giant stockpot left too long on the stove, sending up thick plumes of vapor that drift lazily into the humid air. From the overlook ridge after hours of grueling trek, it looks almost mesmerizing. A natural hot spring on steroids. The kind of geothermal marvel that could power a small city, if anyone dared harness it. In a kinder landscape, this would be a bucket list thermal wonder, drawing crowds for therapeutic soaks or scenic photos. Instead, Boiling Lake stands as one of the planet's most relentlessly hostile bodies of water, perpetually near or at boiling point, shrouded in toxic fumes, and accessible only after a punishing journey that tests body and nerve alike. The paradox reveals itself step by grueling step. Boiling Lake occupies a flooded fumarole, a direct vent to volcanic depths, in the Morne-Trois Pitons National Park, a UNESCO World Heritage Site where Dominica's volcanic backbone breaks the surface. Magma far below heats groundwater circulating through fractured rock, superheating it until it erupts upward into this natural cauldron. In theory, the constant convection should stabilize temperatures, creating a warm, mineral-rich pool. Reality delivers something far deadlier. Surface temperatures hover between 180 and 197 degrees Fahrenheit along the edges, hot enough to scald skin instantly, cook an egg in minutes, or boil away moisture from anything unfortunate enough to touch it. The center? Impossible to measure reliably, because the violent upwelling prevents safe approach. Probes vaporize or melt. The water's pH sits mildly acidic, around 4 to 6, but the real poison comes from dissolved volcanic gases. Sulfur dioxide, carbon dioxide, hydrogen sulfide, wafting off in invisible clouds that sting eyes, burn lungs, and in concentrated pockets can drop a person unconscious before they realize the smell has vanished. The anatomy of this ongoing hazard builds from Dominica's position squarely on the Lesser Antilles volcanic arc. Tectonic subduction fuels constant heat flow. No dramatic eruptions needed, just persistent geothermal pumping. The lake drains and refills episodically, sometimes dropping dramatically over weeks or months, exposing steaming mud and sulfur flats before surging back. These cycles spike risks. Low water levels concentrate gases, trigger small steam explosions, or release sudden bursts of carbon dioxide that pool in depressions like invisible quicksand. In 1901, during one such drain down, 2 people died at the edge from asphyxiation as toxic vapors overwhelmed them. Modern incidents remain rare thanks to strict guide requirements and warnings, but the potential lingers. Earthquakes, heavy rains, or seismic shifts could destabilize the system further, turning a slow boil into explosive release. Surviving, or even reaching, a day here demands respect bordering on obsession. The hike alone qualifies as survival training. 6 to 8 miles round trip through dense rainforest, muddy trails, river crossings, steep ascents and descents into the Valley of Desolation. That valley itself feels apocalyptic. Barren, hissing ground dotted with bubbling sulfur pots, fumaroles spraying scalding steam, cracked earth venting acrid fumes. Invisible hot springs hide under thin crust. One wrong step burns through boots. Guides insist on long pants, sturdy shoes, poles for balance on slippery rocks. Reaching the final ridge overlooking the lake brings no relief. Sheer drops, loose gravel, constant vapor that soaks clothes and irritates airways. No swimming, no dipping. Even approaching the edge risks slipping into water hot enough for third-degree burns across the body. Fumes vary with wind. Some days hikers cough through masks, eyes watering from hydrogen sulfide that numbs smell before it kills. Wildlife avoids the core zone. Birds skirt high, insects thin out. Only extremophile microbes and hardy plants cling to the fringes. The surrounding rainforest teems, but the lake carves a dead zone where heat and chemistry rule supreme. The irony burns hottest in the trek's reward. After hours of sweat, mud, fatigue, you crest the ridge to behold raw geological fury. Churning water the color of molten steel, steam rising in curtains, the low roar of boiling like distant thunder. It's mesmerizing, almost spiritual. Nature flexing muscle without apology. Yet every guide story circles back to caution. People have collapsed from exhaustion on return, slipped on wet rocks near scalding pools, inhaled too much gas during still air moments. Tour operators require licensed guides, partly for navigation, mostly for survival math, knowing when to turn back if weather shifts or fumes thicken. The lake itself changes moods, sometimes calm boil, sometimes violent surge, always indifferent to human awe. Philosophically, Boiling Lake confronts with nature's indifference to accessibility. Beauty demands payment here, not just effort, but vigilance against heat that cooks, gases that suffocate, terrain that punishes. Human spirit shines in those who make the journey. Guides who lead daily, scientists monitoring cycles, hikers chasing the ultimate volcanic high. Yet the place mocks comfort. Water too hot for life as we know it. Fumes too toxic for lingering. Access too arduous for casual visits. Statistics show few fatalities directly from the lake, warnings work, but the real cost hides in sprained ankles, burned feet, respiratory irritation that lingers weeks. The tragedy isn't spectacle, it's how paradise weaponizes its own allure, turning wonder into warning. From Dominica's relentless boil, we pivot to a New Zealand counterpart, one where geothermal fury creates a frying pan expanse that stays scalding year-round, a volcanic skillet masquerading as lake. Lagoon number 6, Frying Pan Lake, Waimangu Cauldron, the world's largest hot spring, Waimangu Volcanic Rift Valley, New Zealand. Envision an enormous steaming basin carved into the volcanic rift of New Zealand's North Island. A vast turquoise expanse stretching the length of several football fields, its surface perpetually rippling with heat-driven convection. Steam rises in lazy columns across the water, carrying the sharp tang of sulfur that clings to clothes and hair long after you've left. The color shifts subtly with light, sometimes vivid aqua, sometimes milky blue-green, thanks to suspended silica and minerals suspended in the warm broth. From the walking tracks that skirt the valley, it looks like a colossal natural infinity pool, serene and inviting under clear skies. In a parallel universe, this would be the ultimate geothermal spa destination, a place to float weightless amid healing waters. Reality delivers a different verdict. Frying Pan Lake ranks as the largest hot spring on Earth, its waters maintained at a steady simmer between 122 and 140 degrees Fahrenheit. Hot enough to scald flesh on prolonged contact, laced with dissolved gases that turn every breath into a calculated risk. The paradox emerges from the valley's violent birth. Frying Pan Lake formed in the Echo Crater, following the catastrophic eruption of Mount Tarawera in 1886. A blast that shredded the landscape, buried villages, and reshaped the geothermal system forever. In the aftermath, hydrothermal activity flooded the crater, creating this massive cauldron fed by deep circulation of rainwater, heated by residual magma chambers. In theory, the constant inflow and outflow should moderate temperatures, diluting toxins and allowing some ecological foothold. Instead, the interconnected system with nearby Inferno Crater Lake creates cyclic behavior. Water levels, temperatures, and gas release fluctuate in patterns tracked since the 1970s. The lake's outflow feeds the Inferno system, where pressure builds and releases in 38-day cycles, sending surges through pipes of fractured rock. The result? Water too hot for most life, acidity hovering mildly corrosive, and constant emission of carbon dioxide, hydrogen sulfide, and other volcanic volatiles that pool in low spots or drift on still days. The anatomy of danger here unfolds quietly but relentlessly. Unlike explosive eruptions, the threat simmers. Surface heat causes instant pain on immersion. Skin reddens in seconds, blisters in minutes. Deeper convection pulls superheated water upward unpredictably. One wrong step near the edge could mean a sudden boil-over splash. Gases pose the stealthier peril. Hydrogen sulfide at low levels announces itself with rotten egg stench. But concentrations spike enough to overwhelm olfactory nerves, letting victims inhale lethal doses unaware. Carbon dioxide creates invisible suffocation pockets in sheltered areas. The valley's trails wind through barren, colorful ground. Reds from iron oxides, yellows from sulfur, whites from silica, dotted with smaller boiling pools and fumaroles that hiss like angry kettles. Signs warn starkly: stay on paths, no dipping hands or feet, turn back if fumes thicken. Incidents remain rare due to access controls and vigilant rangers, but the geothermal zone claims occasional victims. Hikers collapsing from heat exhaustion compounded by gas, or slips into scalding shallows. The lake itself hosts almost no macroscopic life. Extremophile bacteria and algae tint the margins, but fish, amphibians, insects vanish where heat dominates. Surviving a day in the Waimungu Valley means treating every step as a negotiation with an active system. Visitors follow boardwalks and tracks, breathing through scarves on fume-heavy mornings. The air feels thick, humid from steam, laced with minerals that coat the throat. Wildlife adapts peripherally. Birds perch on distant rims, hardy ferns colonize cooler slopes. But the lake proper remains a sterile zone. Rangers patrol, monitoring for changes, sudden level drops signaling shifts in underground plumbing, or gas spikes prompting evacuations. The cyclic link to Inferno Crater adds tension. When that smaller lake rises and heats, Frying Pan sometimes cools slightly as pressure redistributes, but the equilibrium stays precarious. A major seismic event in this tectonically lively rift could fracture conduits, spiking temperatures or gas release dramatically. The irony gleams brightest in the visual feast. After the grueling beauty of the approach, steaming craters, rainbow terraces, bubbling mud, the lake appears almost peaceful, its vast size dwarfing human scale. Steam veils and unveils details, bubbles popping in rhythmic patterns, faint blue glow under sunlight, the low rumble of convection like distant surf. It's mesmerizing, a living geological engine that draws scientists studying hydrothermal dynamics and tourists chasing otherworldly photos. Yet every frame carries the subtext of peril. Barriers, signs, the faint burn in nostrils, reminding that this beauty runs on forces indifferent to admiration. Philosophically, Frying Pan Lake embodies geothermal ambivalence. Heat is both creator and destroyer. The same energy that sculpts silica sinter terraces and paints microbial palettes could scald or suffocate without warning. Human ingenuity builds paths, installs monitoring, educates visitors, yet the lake cycles on its own timetable, uncaring of schedules or safety briefings. Statistics log minimal direct fatalities, controls work. But the subtler cost lingers in heat stress, respiratory irritation, the quiet fear that accompanies every photo op. The real poignancy isn't in spectacle. It's how a place so vividly alive with Earth's inner fire makes survival feel like borrowed time. From New Zealand's simmering giant, we shift to a different extreme, one where the water turns flesh to stone, calcifying anything it touches in a bizarre mineral embrace that preserves while it kills. Lagoon number 7, Lake Natron, the petrifying soda cauldron of northern Tanzania. Imagine a shallow, shimmering expanse in the scorched Rift Valley of northern Tanzania, its waters glowing in unearthly blood red under the relentless African sun. Salt crusts fringe the shores like cracked white lace, while flocks of lesser flamingos wade in eerie synchrony, their pink feathers stark against the crimson mirror. From a distance, or through a telephoto lens, Lake Natron appears almost otherworldly beautiful, a hypersaline sanctuary where life defies expectation. Millions of flamingos breed here annually, turning the lake into a living pink ribbon visible from space. Yet step closer and the illusion fractures. This isn't a nurturing wetland. It's one of nature's most efficient preservatives, a highly alkaline, near-boiling soda lake where the water's chemistry calcifies flesh, mummifies carcasses, and turns unlucky animals into eerie, statue-like relics that stand frozen in time. The paradox hits with brutal clarity. Lake Natron occupies a closed basin in the East African Rift, fed by mineral-rich hot springs bubbling up from volcanic faults. In a balanced ecosystem, those minerals might nourish unique biodiversity. Instead, the lake concentrates sodium carbonate, washing soda, to extreme levels, pushing pH values often past 10, sometimes climbing toward 12, rivaling household lye or ammonia solutions. Water temperatures hover between 104 and 140 degrees Fahrenheit in shallows, hot enough to scald on contact. Evaporation in the arid climate intensifies everything. Salinity spikes, alkalinity concentrates, and the water becomes a caustic brew that denatures proteins on contact. Animals that die here, birds misjudging a landing, mammals straying too far, don't simply decompose. The high soda content draws moisture from tissues, triggering rapid calcification. Soft tissues harden into a mineral shell. Bones and feathers preserve in lifelike poses. Photographer Nick Brandt captured haunting images in the early 2010s. A calcified eagle clutching a branch, a flamingo frozen mid-stride. Bodies turned to stone, not by myth, but by relentless chemistry, echoing ancient Egyptian mummification techniques. The anatomy of lethality builds slowly, but inexorably. No dramatic explosion here, no sudden gas cloud, just persistent hostility. The alkalinity burns skin and eyes on immersion. Prolonged exposure causes severe chemical burns, tissue damage, blindness in extreme cases. Inhaled ammonia vapors from evaporating soda irritate lungs, triggering respiratory distress. Cyanobacteria mats thriving in the nutrient soup produce occasional toxins, though flamingos filter feed selectively to survive. The heat compounds every risk. Dehydration strikes fast in the surrounding desert, while the lake's warmth accelerates metabolic stress for any non-adapted creature. Humans fare better with caution. No known direct fatalities from the water itself, but incidents occur. In 2007, a helicopter carrying journalists crashed near the shore. Survivors describe the caustic spray stinging exposed skin. Local Maasai communities respect the lake, using its edges sparingly, aware that what sustains flamingos destroys outsiders. Surviving, or attempting, a day around Natron demands meticulous preparation. Visitors trek in with guides, sticking to dry vantage points far from the waterline. The air shimmers with heat haze, carrying a sharp, soapy scent that coats the throat. Flamingos thrive because their specialized bills filter the alkaline soup for cyanobacteria and brine shrimp, their legs coated in natural oils resisting burns. Other life struggles. Few fish survive. Amphibians absent. Insects sparse except extremophiles. Birds that falter mid-flight or land poorly end up as calcified monuments, their forms eerily preserved for months or years until erosion or scavengers intervene. The surrounding soda flats crack underfoot, hiding hot springs that could scald through boots. Wind shifts carry stinging spray. One gust toward your face means instant eye irritation, coughing fits from ammonia. Photography tempts closer approaches, but wiser souls keep distance. Beauty here exacts a price in caution and discomfort. The irony slices deepest in the visual poetry. Amid desolation, life explodes in color. Pink multitudes against red water. White soda efflorescences framing the scene like abstract art. It's mesmerizing, almost meditative. Nature's stark reminder that adaptation turns poison into paradise for the few. Yet for most, the same chemistry spells doom. The calcified carcasses aren't horror props, they're cautionary tales. Silent witnesses to how quickly beauty becomes barrier. Scientists study the lake as a model for extremophile biology and ancient preservation processes, while tourists chase the flamingo spectacle from safe perches. Access remains limited. No casual swims, no dipping toes, because one misstep means chemical burns or worse. Philosophically, Lake Natron forces reflection on survival's narrow margins. What kills one species nurtures another. The same caustic bath that petrifies outsiders sustains vast colonies of pink icons. Human curiosity draws us near, yet wisdom keeps us back, admiring from afar the dance of adaptation against hostility. Statistics show no mass human tragedies here, unlike gas-burst lakes. But the subtle toll lingers. Burns from accidental contact, respiratory issues from fumes, the quiet unease of standing before a place that mummifies the careless. The real poignancy lies in duality, a deadly mirror reflecting life's tenacity, where death sculpts enduring forms from the very elements meant to destroy. From Tanzania's calcifying red enigma, we move to a radioactive ghost, one where Cold War secrets turned a small basin into the planet's most contaminated natural puddle, lethal even in trace exposure. Lagoon number 8, Berkeley Pit, the toxic Superfund swimming hole of Butte, Montana, USA. Picture a gaping wound in the earth, the size of a small city block, carved straight into the hills of western Montana. Water fills the former open-pit copper mine to a depth of hundreds of feet, its surface shifting through shades of electric turquoise to rusty orange-brown, depending on the light and season. From the viewing platform along the fence perimeter, it looks almost inviting, a massive, otherworldly lake set against snow-dusted mountains and pine forests. Tourists snap photos remarking on the surreal color that seems stolen from a sci-fi set. Informational signs explain the history of mining riches that built entire towns. Yet every warning label, every chain link barrier, every posted pH reading tells the same grim truth. This is one of the most contaminated bodies of water on the planet. A slow-motion environmental disaster, still growing, still lethal, still impossible to remediate cleanly. Berkeley Pit isn't just polluted. It's a man-made lagoon, engineered by greed and gravity into a perpetual acid-metal soup that kills anything it touches. The paradox stands stark against the American West's mythology of opportunity. Butte once called itself the richest hill on Earth. From the late 1800s through much of the 20th century, Underground shafts and then massive open pit operations pulled billions of pounds of copper, along with silver, gold, manganese, and zinc. The Berkeley pit opened in 1955, swallowing entire neighborhoods as it expanded. By the time pumps stopped in 1983, after Anaconda Copper shut down, the hole had reached 1,700 feet deep and nearly a mile across. Groundwater, surface runoff, and snowmelt began refilling it immediately. Without constant dewatering, the pit lake rises about 6 to 10 feet per year. Today it holds roughly 50 billion gallons of water, laced with sulfuric acid, heavy metals, copper, arsenic, cadmium, zinc, lead, and radioactive traces from associated uranium deposits. The pH hovers between 2.5 and 3, acidic enough to dissolve metal tools left overnight, burn skin on contact, and kill most aquatic life instantly. The anatomy of contamination traces a textbook case of resource curse turned environmental catastrophe. As ore oxidized underground, bacteria accelerated the process, generating acid mine drainage. Sulfides in the rock reacted with air and water to form sulfuric acid, which leached metals from surrounding rock into solution. When pumping ceased, the rising water table flushed decades of accumulated toxins into one concentrated basin. Arsenic levels exceed drinking water standards by thousands of times, cadmium and zinc by tens of thousands. Iron and aluminum give the characteristic rusty hue, while copper ions tint sections vivid blue-green. The water stays eerily stratified in places. Colder, denser bottom layers trap heavier metals, creating zones of varying lethality. Birds provide the most visible victims. Hundreds of snow geese landed during a spring migration in 2010, mistaking the colorful surface for safe water. Within hours, most died from acute metal poisoning and acid burns to digestive tracts. Autopsies showed gizzards eroded, livers overloaded with toxins. Similar, smaller incidents occur regularly. The pit claims wildlife almost yearly, despite netting and noisemakers meant to scare flocks away. Surviving, or rather, not dying, near Berkeley Pit requires strict separation. The site remains a Superfund National Priorities List location, one of America's most contaminated. A treatment plant pumps water from an underground aquifer before it reaches the pit, partially treats outflow, and discharges it downstream under tight regulation. Yet the pit lake itself grows unchecked. Projections show it could overflow into the Silver Bow Creek watershed by the mid-2030s unless new controls intervene. Visitors walk fence platforms hundreds of feet above the waterline. Touching the water is impossible without breaching multiple barriers. Even airborne particles carry risk. Wind can lift metal-laden dust from exposed tailing piles nearby, though the pit's water stays largely contained. No swimming, no fishing, no dipping a hand for a dare. Local lore includes stories of drunk teenagers testing boundaries in the 80s and 90s. Severe chemical burns, hospitalizations, at least one confirmed death from falling in and drowning in the toxic broth. The water doesn't just poison, its density and viscosity make escape nearly impossible once immersed. The irony cuts deepest in Butte's reinvention narrative. The city has pivoted to tourism, historic preservation, and outdoor recreation. The pit viewing stand draws thousands annually, part of a Copper King legacy trail that celebrates mining heritage while quietly acknowledging its scars. Informational plaques explain chemistry and remediation efforts with clinical detachment. Yet the turquoise monster dominates every vista, a constant reminder that industrial triumph came at the price of a wound that refuses to heal. Scientists monitor relentlessly: pH, metal concentrations, water levels, searching for ways to stabilize or treat without bankrupting the cleanup fund. Proposals range from advanced lime precipitation to biotechnology using metal-eating microbes. None offer quick fixes. The volume is simply too vast, the chemistry too stubborn. Philosophically, Berkeley Pit confronts humanity with the long shadow of extraction. We dug for wealth, left a hole, and nature filled it with poison of our own making. The color mesmerizes, the scale awes. Yet both stem from the same processes that devastated ecosystems downstream for generations. Human resilience appears in ongoing cleanup, in Butte's determination to reclaim identity beyond the pit. Yet the water rises inexorably, indifferent to lawsuits, regulations, or good intentions. Statistics track rising levels and falling remediation budgets, but miss the subtler cost. Communities living beside a slow apocalypse. Children growing up with the pit as backyard horizon. The quiet knowledge that beauty here was purchased with legacy pollution measured in centuries. From Montana's man-made toxic jewel, we descend into an oceanic nightmare. One where a deep submarine caldera traps hydrogen sulfide in concentrations that could turn water into poison gas at any moment. Lagoon number 9, the hot tub of despair, brine pool, the underwater killer of the Gulf of Mexico. Envision descending through endless blue into the abyssal darkness of the continental slope, 3,300 feet below the Gulf of Mexico's surface. Suddenly, the seafloor drops away into a crater-like depression, and there it sits, a shimmering, rectangular pool of dense, hypersaline brine rising like a ghostly bathtub 12 feet above the surrounding sediment. The edges glow with eerie white and red mineral crusts, bacterial mats and carbonate precipitates, framing the boundary like necrotic flesh. Inside, the water looks almost still, slightly warmer than the surrounding cold, deep sea, its surface rippling with subtle density currents. From the vantage of a remotely operated vehicle's lights, it appears mesmerizing. A hidden lagoon in the ocean's basement that could pass for an alien art installation. In truth, this is one of the planet's most merciless traps. An anoxic, hydrogen sulfide-charged brine pool nicknamed the Hot Tub of Despair, where anything that crosses the invisible threshold dies almost instantly, preserved in macabre detail as if time itself froze. The paradox lurks in the chemistry of creation. These brine pools form where ancient salt layers, remnants of evaporated prehistoric seas, dissolve slowly into seawater through faults and seeps. In the Gulf, shifting tectonic plates and salt tectonics push supersaturated fluids upward from deep reservoirs. The brine, 4 to 5 times saltier than normal seawater, is denser than the overlying ocean water, so it pools in seafloor depressions without mixing. Temperature hovers around 66 degrees Fahrenheit, warmer than the frigid ambient deep sea due to geothermal heat and insulation, creating a stable interface. Methane and hydrogen sulfide bubble up from cold seeps nearby, dissolving into the brine and fueling chemosynthetic communities at the edges. Tube worms, mussels, clams, thriving in symbiosis with bacteria that oxidize the toxic gases for energy. In a gentler system, these oases would represent life's triumph over darkness. Here, the same toxins that sustain the rim condemn intruders to instant death. Oxygen levels plummet to near zero inside. Hydrogen sulfide concentrations spike lethally. Methane adds asphyxiation risk, and extreme salinity triggers osmotic shock that ruptures cells in seconds. The anatomy of doom plays out in slow-motion horror for any creature crossing the line. Fish, crabs, shrimp, amphipods. Drawn perhaps by the faint chemosynthetic glow or simply unlucky drift, sink into the brine and stop moving almost immediately. Their bodies don't decay. The anoxia and toxicity halt bacterial decomposition. Instead, they mummify or calcify in lifelike poses, legs outstretched, mouths agape, as if caught mid-struggle. ROV footage shows carpets of dead crustaceans blanketing the bottom, preserved for months or years like Pompeii victims in brine instead of ash. Larger animals fare no better. A misplaced step by a submersible arm or careless remotely operated vehicle maneuver risks equipment failure from corrosion or short-circuiting in the conductive soup. No large predators hunt here. The pool's lethality creates a no-go zone even for deep-sea scavengers. The surrounding cold seep ecosystem pulses with life. Mussels clustering thickly along the rim, tube worms swaying in gentle currents, but the boundary remains absolute. Cross it, and biology ends. Surviving, or observing, a day in proximity demands technology and distance. Human presence here relies entirely on robotic proxies. Deep-sea ROVs like Hercules or Jason, deployed from research vessels, beaming live video to surface teams. Divers cannot reach these depths without specialized saturation systems far beyond recreational limits. Even then, no one enters the brine intentionally. Contact would corrode seals, foul thrusters, ruin sensors. The water's density difference creates a visible halocline shimmer, a mirage-like barrier warning of peril below. Marine biologists studying these sites describe the eerie quiet. No bubbles escaping upward, gases stay dissolved under pressure. Only the faint hiss of ROV hydraulics and the occasional crunch of a preserved carcass under manipulator arms. Wildlife beyond the rim adapts ingeniously. Chemosynthetic clams filter feed on sulfide-oxidizing bacteria. But inside, sterility reigns supreme, except for extremophile microbes that metabolize the very toxins killing everything else. The irony gleams coldly in the footage. What should be a barren wasteland teems with fringe life. Red bacterial mats carpeting the edges, vesicomyid clams pulsing like slow hearts, sibyl-glynnid worms extending feathery plumes to harvest chemicals. The pool itself looks deceptively calm, its surface reflecting rove lights in hypnotic patterns. Yet every frame carries the subtext of mass graves, countless small corpses frozen in eternal rigor, testament to nature's indifference. Scientists nickname it the hot tub of despair, precisely because the warmth and stillness mock the horror, an inviting bath that embalmed its guests. Exploration videos go viral for the surreal visuals, drawing armchair wonder while underscoring the abyss's rules. No mercy for the unprepared. Philosophically, the hot tub of despair strips survival to its rawest equation: adaptation or annihilation. Life clings to the razor edge where toxicity fuels energy, but 1 millimeter too far spells instant oblivion. Human curiosity sends machines where flesh cannot follow, mapping oases amid desolation. Yet the brine remains sovereign, preserving death in perfect detail, indifferent to awe or analysis. No body count exists here beyond ecological snapshots, but the preserved carcasses speak volumes. Beauty born of poison, where the line between haven and grave thins to nothing. The real tragedy isn't spectacle. It's how the deep ocean hides pockets of such absolute lethality. Reminders that vast unknowns lurk beneath surfaces we think we understand. From the Gulf's abyssal embalming chamber, we ascend to a high-altitude enigma. One where extreme salinity and arsenic create waters so hostile they support almost nothing, turning a plateau lake into a toxic mirror under thin air. Lagoon number 10, Laguna Verde, the poisoned emerald of Licancabur Volcano, Bolivia. Visualize standing at over 14,000 feet above sea level on the Altiplano, where thin air makes every breath feel borrowed. Before you stretches a small, jewel-like lake pressed against the base of the symmetrical cone of Volcan Licancabur. The water gleams an intense emerald green, almost luminous under the high-altitude sun, ringed by stark white mineral deposits and the barren red-brown volcanic rock. No waves lap the shore, the surface lies mirror still, reflecting the cobalt sky and distant snow-capped peaks. Flamingos sometimes wade the shallows and other nearby salars, but here, almost nothing stirs. From afar, or in travel brochures pushing Bolivia's surreal landscapes, Laguna Verde promises postcard perfection, a hidden gem in Eduardo Avaroa Andean Fauna National Reserve. Up close, the truth emerges sharp and bitter. This isn't refreshment. It's one of the most naturally toxic lagoons on the continent, saturated with arsenic, copper, lead, and other heavy metals leached straight from volcanic guts, turning every drop into slow poison. The paradox cuts through the rarefied atmosphere. Laguna Verde sits in a closed basin fed by hydrothermal springs and snowmelt trickling down Laconcaber's flanks. The volcano, still considered potentially active, though quiet for centuries, pushes mineral-rich fluids upward through fractures. In a different geological story, those minerals might create therapeutic hot springs or unique microbial havens. Instead, the high evaporation rate in this arid rain shadow zone concentrates everything relentlessly. Arsenic levels soar far beyond any safe threshold, often measured in milligrams per liter, where drinking water limits sit in micrograms. Copper dissolves in abundance, giving the signature green hue that looks inviting from a distance, but signals lethality. Lead, sulfur compounds, and other volcanogenic elements join the cocktail. The water's pH swings alkaline in places from dissolved carbonates, yet the heavy metal load dominates danger. Touch it? Skin irritates immediately. Drink it? Acute poisoning sets in fast. Vomiting, abdominal pain, organ failure. Chronic exposure scars lungs, skin, nervous system. Local folklore whispers of shepherds who tasted the water on desperate treks and never recovered fully. The anatomy of toxicity traces to the Andean volcanic arc's restless subduction. Laconcaber's magma chamber, cooling slowly beneath, releases fluids carrying dissolved metals from deep crustal rocks. These ascend, mix with meteoric water, and pool in the depression without outlet. No dramatic limnic eruption here, no boiling surface, just steady concentration as sun bakes away volume year after year. Seasonal fluctuations occur. Wetter periods dilute slightly, dry spells spike lethality. The lake occasionally turns milky or shifts shades as precipitates form, but the core poison remains. Wildlife avoids the center. Hardy extremophiles, certain algae, bacteria, cling to margins where dilution allows tenuous survival. Birds rarely land, mammals steer clear. Humans pass through on four-wheel drive tours or border crossings to Chile, but guides enforce strict no-contact rules. Incidents stay anecdotal. Rash from splashed spray, nausea from inhaled dust kicked up by wind. But the risk profile screams caution. One prolonged exposure could mean chelation therapy or worse. Surviving, or wisely avoiding, a day at Laguna Verde means treating the site like a chemistry hazard zone. Visitors arrive by jeep after bone-rattling drives over unpaved altiplano tracks, lungs already laboring from altitude sickness. The air feels crisp, almost sterile, carrying faint metallic tang when wind stirs evaporite crusts around the shore. No trails lead to the water's edge. Observation stays distant, binoculars or zoom lenses capturing the hypnotic color without risk. Local Aymara and Quechua communities historically revered Laconcaber as sacred, climbing its slopes for ceremonies while giving the lake wide berth. Modern tourism brings selfie seekers who pose against the green backdrop, but wiser operators keep groups uphill, windward. Dust from dried margins carries trace arsenic. Prolonged breathing invites long-term worry. No swimming, no dipping fingers, no filling bottles for souvenirs. The green tempts, but poison lurks in every shimmer. The irony gleams brightest under that merciless sun. Amid desolation, cracked earth, sparse ichu grass, distant vicuñas grazing higher slopes, the lagoon radiates unearthly beauty. The emerald glow contrasts volcanic blacks and reds like abstract painting. Sunsets paint the water molten gold green. It's mesmerizing, almost spiritual. A reminder of Earth's raw alchemy turning rock to liquid jewel. Yet every photon bouncing off that surface carries warning. Beauty forged in toxicity. Scientists sample cautiously, studying how microbes metabolize arsenic, or how metals cycle in closed basins. Tourists chase the view for social media immortality, while guides recount quiet tales of those who ignored boundaries and paid in health. The lake answers no pleas, indifferent to awe or fear. Philosophically, Laguna Verde strips away illusions of benign nature. High places promise clarity, purity. This one delivers lethal truth. Life adapts at edges. Microbes thrive where metals should kill. Yet the center declares absolute exclusion. Human curiosity draws near, yet survival demands retreat. No dramatic body count marks this place, unlike gas burst craters or acid baths, but the subtle toll lingers. Potential cancers in exposed populations, ecosystems pushed to brink, the quiet dread of a landscape that preserves beauty by poisoning intruders. The real poignancy isn't flash, it's how paradise can crystallize danger, where one sip from the emerald cup buys passage to slow ruin. From Bolivia's arsenic-laced jewel, we plunge toward the frozen extreme, one where salinity defies Antarctic cold, keeping water liquid in -50 degrees, while turning it into a caustic brine that corrodes anything it meets. Lagoon number 11, Don Juan Pond, the unfreezable brine abyss of the McMurdo Dry Valleys, Antarctica. Imagine trekking across the stark, wind-scoured silence of Antarctica's McMurdo Dry Valleys, where precipitation barely registers and temperatures plunge to levels that shatter ordinary thermometers. Amid the cracked brown rock and frozen ridges of Wright Valley stands a small, shallow depression, no more than 300 meters long and 100 meters wide, filled with a dark, syrupy liquid that refuses to freeze even when the air drops to -58 degrees Fahrenheit. The surface gleams dully under the pale polar sun, edged by thin white salt crusts that crunch under boots like brittle glass. No ripples disturb it, no life stirs visibly across its expanse. From a scientific outpost or a rare expedition photo, Don Juan Pond appears almost mundane, a forgotten puddle in the world's driest desert. Yet this is arguably the saltiest natural body of water on Earth, a hypersaline cauldron dominated by calcium chloride at concentrations pushing 44% or higher, turning ordinary water into something closer to molten salt than liquid refreshment. The paradox freezes in place the moment you understand its chemistry. Most Antarctic waters lock solid under extreme cold. Even seawater forms thick ice shelves. Don Juan Pond defies that rule through sheer osmotic brutality. The extreme salinity depresses the freezing point dramatically, far beyond the -1.8 degrees typical of ocean brine, allowing the pond to remain liquid in conditions that would solidify pure water instantly. Fed by subsurface groundwater seeping through fractured rock, and perhaps minor snowmelt trickling from surrounding glaciers, the pond accumulates salts leached from ancient marine evaporites buried deep in the valley floor. No outlet exists. Evaporation in the hyper-arid air concentrates everything relentlessly. Calcium chloride dominates the mix, creating a dense, viscous fluid that feels oily to the touch, if anyone dared reach in. Trace elements, magnesium, sodium, sulfates, add to the cocktail, but the calcium chloride reigns supreme, making this pond saltier than the Dead Sea by a significant margin, and earning it titles as the planet's most saline natural water body. The anatomy of danger here unfolds in quiet, insidious ways rather than spectacular bursts. Touch the liquid? Skin contacts a solution so hypertonic it draws water from cells instantly, causing severe osmotic burns, tissue dehydration, and chemical irritation akin to strong caustic exposure. Prolonged immersion would desiccate flesh like jerky left in the sun, while the cold amplifies shock. Body heat transfers rapidly into the chilled brine, risking hypothermia even as salinity prevents outright freezing on contact. Inhalation risks rise too. Wind whips fine salt aerosols carrying chloride ions that corrode lungs and eyes, triggering inflammation or worse in sensitive individuals. No macroscopic life survives inside. Bacteria struggle at the fringes, perhaps extremophiles metabolizing the harsh chemistry. But fish, algae, invertebrates? Absent. The surrounding dry valleys host hardy microbes in soils and occasional mummified seal carcasses blown inland centuries ago. Yet the pond carves its own sterile zone. Scientists approach in sealed gear, collecting samples with long poles or remote samplers to avoid direct contact. One slip on icy rock nearby could mean a dunk that ends an agonizing rescue. or no rescue at all in such remote isolation. Surviving, or wisely observing, a day at Don Juan Pond requires Antarctic-grade preparation bordering on paranoia. Researchers arrive by helicopter or overland traverse from distant bases like McMurdo or Scott, bundled in extreme cold-weather suits that insulate against -40 winds while protecting against splash hazards. The air bites with metallic dryness. Every breath feels thin, laced with faint chemical sharpness from evaporated salts. No casual waiting, no curious finger dips. The pond's edges stay off-limits, except under strict protocols. Even standing downwind risks inhaling corrosive mist on gusty days. Wildlife gives it wide berth. Skuas and penguins avoid the valleys entirely. Seals rarely venture this far inland. The pond's stillness mesmerizes, dark mirror reflecting jagged Asgard Range peaks. But every shimmer carries warning. Sampling missions involve painstaking work, drilling ice cores nearby, measuring conductivity, tracking subtle level changes as subsurface flow varies seasonally. A major seismic event or glacial shift could alter hydrology, perhaps diluting or concentrating the brine further. But the core hostility endures. The irony crystallizes under that endless polar light. Amid one of Earth's most lifeless landscapes, valleys so dry NASA uses them to simulate Mars, the pond persists as liquid defiance, a stubborn puddle refusing to join the ice. Its darkness contrasts blinding white snowfields on distant ridges. The salt rims sparkle like frost diamonds. It's hauntingly beautiful, almost minimalist art. Nature distilling hostility into serene geometry. Scientists flock here not for thrills, but for clues. How such extreme chemistry sustains trace microbial life. What it reveals about potential habitability on other worlds, like Mars or Europa. Yet the beauty exacts isolation. Access demands multi-million-dollar logistics, permits, survival training. Tourists never come. Even most Antarctic visitors never see it. The pond answers no admiration, indifferent to probes or poetry. Philosophically, Don Juan Pond confronts with extreme stripped bare. In a continent defined by frozen desolation, it chooses liquid permanence through poison. Salinity as armor against cold, yet barrier to life. Human ingenuity reaches it with machines and models, decoding secrets while keeping flesh at bay. No dramatic fatalities scar its record. Remoteness and restrictions prevent mishaps. But the subtle peril lingers. Osmotic shock waiting for the careless. Corrosion eating at equipment left too long. The quiet knowledge that one of Earth's strangest waters would preserve your remains in mummified silence if you fell in. The real poignancy isn't spectacle. It's how utter hostility masquerades as calm persistence, a tiny mirror reflecting that survival sometimes demands becoming lethal to everything else. From Antarctica's unfreezable salt trap, we descend toward the final abyss, one where volcanic depths meet ocean trenches in a submerged caldera of hydrogen sulfide so concentrated it turns water fatal in moments. The last killer lagoon on our list. Lagoon number 12. The Hot Tub of Despair, Gulf of Mexico Brine Pool. The submerged graveyard of the deep. Descend through layers of darkening blue until sunlight fades completely. 3,300 feet down on the continental slope of the Gulf of Mexico. There, in the cold, crushing dark, the seafloor suddenly dips into a rectangular depression. A shimmering boundary appears, dense, dark brine rising like a sunken bathtub, its surface 12 feet higher than the surrounding sediment plain. White and red bacterial mats fringe the edges in ghostly halos, while carbonate crusts form a brittle shoreline. The water inside looks almost tranquil, slightly warmer than the frigid ambient deep, rippling faintly with invisible density currents. To a remotely operated vehicle's floodlights, it resembles a secret lagoon hidden in the ocean's basement, an otherworldly pool that could inspire awe, if not for the carpet of motionless crabs, amphipods, and occasional fish lying preserved on the bottom in perfect frozen poses. This is the infamous hot tub of despair, one of the most unforgiving natural features ever documented. A hypersaline, anoxic brine pool saturated with hydrogen sulfide and methane, where crossing the invisible halocline means instant death followed by eerie embalming. The paradox reveals itself in layers of lethal chemistry. Brine pools form where ancient salt domes, remnants of prehistoric seas, dissolve slowly through faults, releasing supersaturated fluids heavier than seawater. In the Gulf, salt tectonics and hydrocarbon seeps create these isolated basins. The brine here reaches 4 to 5 times the salinity of normal ocean water, dominated by sodium chloride laced with calcium, magnesium, and other ions. Density keeps it stratified, no mixing with overlying seawater, forming a stable interface that acts like a liquid floor. Temperature hovers around 66 degrees Fahrenheit, warmer than the surrounding near-freezing depths due to geothermal flux and insulation from the dense fluid. Methane bubbles up from cold seeps, dissolving abundantly. Hydrogen sulfide seeps in from bacterial sulfate reduction in anoxic sediments or deeper hydrocarbon sources. Oxygen drops to undetectable levels inside the pool. The combination creates a toxic cocktail. Extreme salinity causes osmotic shock that dehydrates cells instantly. Hydrogen sulfide poisons respiration by binding to cytochrome C oxidase. Methane adds asphyxiation potential under pressure. And total anoxia starves aerobic life. Anything organic crossing the boundary, fish drawn by faint chemical cues, crabs scuttling too close, succumbs in seconds to minutes, bodies halting decomposition in the sterile, preservative brew. The anatomy of this submerged killer unfolds without fanfare or warning. No explosive release like Nyos, no scalding heat like boiling lake. Just quiet, absolute exclusion. The halocline shimmers visibly under lights, a mirage barrier where density gradients bend light. Creatures that drift or blunder across lose buoyancy control first. Then osmoregulation fails. Cells shrivel as water rushes out. Membranes rupture. Proteins denature. Hydrogen sulfide floods gills or skin, blocking oxygen transport even if trace amounts lingered. Death arrives swiftly, often without struggle. Limbs stiffen, eyes glaze, bodies sink to join the graveyard floor. Preservation happens fast. Anoxic conditions halt bacterial decay. High salinity dehydrates tissues like natural mummification. Sulfides sometimes trigger minor mineralization. ROV footage shows layers of dead amphipods, crabs with legs outstretched in eternal freeze frame, occasional larger fish curled in rigor. The edges teem with paradox. Chemosynthetic mussels cluster thickly, their symbiotic bacteria oxidizing sulfide for energy. Tube worms sway in red-plumed crowns. Clams pulse slowly. These extremophiles build the rim's living wall, stabilizing the pool while thriving on the very toxins that doom outsiders. Inside, sterility except for rare anaerobic microbes scraping a living from residual chemistry. Surviving, or merely witnessing, this abyss requires removing humanity entirely. No diver reaches 3,300 feet without saturation diving systems far beyond limits. Even then, contact remains forbidden. Exploration relies on ROVs like Hercules or Jason, launched from research ships, piloted remotely while teams on deck watch monitors in tense silence. The descent takes hours. Pressure hulls creak, lights pierce ink-black water, sensors register dropping temperature, then the sudden warmth signature. Approaching means caution. Thrusters avoid stirring sediment clouds that could obscure views or foul equipment. Manipulator arms sample carefully, never dipping fully into brine for fear of corrosion or shorting electronics in conductive fluid. The air aboard ship feels charged. Faint metallic scent from recirculated systems, low hum of generators, quiet murmurs as scientists narrate live feeds. Wildlife beyond the rim adapts in ways that mock the pool's lethality. Shrimp graze bacterial mats, fish skirt edges, but the interior declares zero tolerance. Wind doesn't exist here. Currents barely stir. Only the ROV's prop wash creates temporary ripples across the deadly mirror. The irony haunts every frame of deep-sea video. What should be barren void pulses with fringe vitality. Mussel beds thick as pavement. Tube worms like crimson feathers waving in slow-motion current. The brine's dark surface reflects lights hypnotically, almost inviting. Warm, still, sheltered from crushing pressure above. Yet the graveyard below tells truth. Countless small corpses embalmed in perfect detail. Silent monuments to nature's razor line between oasis and oblivion. Researchers nickname it the hot tub of despair for the cruel joke. Warmth promising comfort, brine delivering death. Viral clips circulate among marine biologists and ocean enthusiasts, drawing gasps at the surreal visuals while underscoring the deep's unforgiving rule. No casual tourism reaches these depths, only multi-million-dollar expeditions probe, mapping cold seep ecosystems that hint at life on Europa or Enceladus. Philosophically, the hot tub of despair distills survival to its cruelest binary. Life clings tenaciously to the boundary where poison fuels chemosynthesis. Yet 1 centimeter too far erases everything. Human reach extends via robots into places flesh cannot follow, decoding how extremophiles turn lethality into livelihood, while the pool preserves its victims in timeless mockery. No statistics tally deaths. Too remote, too non-human. But the preserved remains speak volumes. Beauty forged from exclusion, where the abyss hides pockets of absolute finality, beneath surfaces we barely comprehend. The real tragedy isn't the body count. It's how the ocean's hidden lagoons reveal nature's indifference, creating refuges ringed by graves, indifferent to wonder or warning. From the Gulf's abyssal embalmer, we arrive at the final reckoning. One last frozen extreme where salinity battles polar cold in a caustic mirror under thinning atmosphere. Closing our chronicle of lagoons, where survival ends at the water's edge. Lagoon number 13, Blood Falls, the crimson bleed of Taylor Glacier, Antarctica. Picture the frozen white expanse of Taylor Glacier in the McMurdo Dry Valleys, a river of ancient ice crawling slowly toward the iron oxide-stained tongue where it meets the barren valley floor. From cracks in the glacier's snout, a vivid stream of blood-red water pours out year-round, staining the ice and snow in rivulets that look exactly like fresh arterial flow against the blinding white. The color is so intense, so unnatural in this sterile polar desert, that early explorers thought they had stumbled on literal, bleeding rock. From a distance, or in the iconic aerial photographs that have circled the internet for decades, Blood Falls appears almost theatrical, a wound in the ice that refuses to clot. Up close, standing on the wind-blasted moraine with goggles fogging from your own breath, the truth settles colder than the -40 air. This isn't blood. It's hypersaline, iron-rich, subglacial brine so anoxic and mineral-laden that it turns rusty on contact with oxygen. A 5 million-year-old chemical ghost leaking from a buried pocket sealed beneath half a mile of glacier. The paradox freezes solid the instant you grasp its age and isolation. Beneath Taylor Glacier lies a deep subglacial lake. Lake Willans is nearby, but this pocket is older, more extreme, trapped when the East Antarctic ice sheet advanced during the Pliocene. For roughly 5 million years, this brine has sat cut off from the surface world. No light, no freshwater recharge, no oxygen exchange. Geothermal heat from residual volcanic activity and insulation from the thick ice keep it liquid despite temperatures well below freezing. Salinity reaches around 24%, more than twice that of seawater, dominated by sodium chloride with significant calcium, magnesium, sulfate, and iron too. The extreme anoxia preserves iron in its reduced, soluble ferrous state. When the brine finds a fracture and seeps upward through basal crevasses, it meets atmospheric oxygen for the first time in eons. Iron 2 oxidizes instantly to iron 3, forming ferric oxyhydroxides, the classic rust-red color that gives Blood Falls its name. The outflow never stops because hydrostatic pressure from the overlying ice forces the dense brine out continuously. A slow, arterial drip that paints the glacier's snout crimson no matter the season. The anatomy of lethality here is subtle, cumulative, almost elegant in its hostility. Touch the outflow? The water feels oily, unnaturally heavy, and bitterly cold. Immediate osmotic shock hits exposed skin. Cells dehydrate as water rushes outward into the hypertonic fluid, causing chemical frostbite, even though the temperature hovers just above freezing. Iron oxides and other metals irritate mucous membranes. Prolonged contact risks severe dermatitis or ulceration. Ingest even a small amount? Heavy metal toxicity compounds osmotic damage. Arsenic traces, manganese, other volcanogenic elements leached from underlying bedrock trigger nausea, organ stress, neurological symptoms. The anoxia that preserved the brine underground means almost no dissolved oxygen survives to the surface. Any aerobic organism plunged into the flow suffocates rapidly. Microbial life exists, astonishingly, but only extremophiles. Iron-oxidizing bacteria, related to Acidithiobacillus and Mary profundus, form the rusty mats, chemolithoautotrophs that derive energy from oxidizing the very iron that colors the falls. Sulfate reducers and methanogens lurk deeper in the anoxic core, scraping existence from sulfur and carbon compounds in total darkness. Nothing macroscopic survives. No fish, no algae beyond microbial films, no insects. The surrounding dry valleys already rank among Earth's most barren places. Blood Falls carves an even stricter exclusion zone. Surviving, or studying, a day at Blood Falls demands polar-grade obsession. Researchers arrive by helicopter from McMurdo Station or Scott Base, dressed in multiple insulated layers, face masks against wind-driven ice crystals, crampons biting frozen moraine. The air tastes metallic from blowing dust and faint sulfur notes wafting off the flow. Sampling requires long poles, sterile bottles lowered into the red stream without direct contact. Gloves come away stained orange-brown. Drilling through the glacier to reach the subglacial source has happened. Hot water drills punch down hundreds of meters. But every expedition treats the brine like radioactive material. Triple bagging samples, decontaminating gear, monitoring for spills that could contaminate downstream ice. No casual visitors reach this remote corner. Permits, logistics, and environmental protocols keep it off casual tourist maps. Wildlife stays distant. Skuas wheel high overhead but never land near the crimson stain. Seals and penguins avoid the dry valleys entirely. The falls themselves hiss faintly as brine meets air, tiny bubbles popping from degassing methane and carbon dioxide trapped for millennia. The irony burns coldest under the pale Antarctic sun. Amid utter desolation, cracked granite, wind-polished dolerite, silence broken only by katabatic gusts, the blood-red cascade pulses with defiant vitality. It looks violent, almost alive. A wound that never heals, yet sustains a hidden microbial universe. The rusty stain spreads across white ice like abstract expressionist painting. Time-lapse sequences show the flow pulsing stronger in summer melt pulses, weaker in deepest winter darkness. Scientists call it one of the best Mars analogs on Earth. Subglacial brines, iron oxidation, chemosynthetic life in perpetual night, fueling astrobiology missions searching for signs beneath Martian ice caps or Europa's ocean. Yet the same chemistry that intrigues also repels. Every drop carries 5 million years of isolation, turned toxic on exposure. No mass deaths mark Blood Falls, no limnite clouds, no scalding surges, but the slow poison waits for anyone foolish enough to drink or immerse. One accidental swallow could mean chelation, dialysis, permanent damage. Philosophically, Blood Falls closes our journey with brutal elegance. In the planet's most lifeless desert, beneath the thickest ice, life persisted in darkness for eons. then leaked to the surface as poison dressed in scarlet. It reminds us that survival can mean becoming lethal to everything else, that beauty often emerges from exclusion, that the Earth still hides pockets of ancient chemistry indifferent to human wonder or horror. We began with turquoise acid baths and blue flame infernos, moved through suffocating gas clouds and calcifying soda mirrors, descended to abyssal embalming pools, and ended here, a frozen continent bleeding rust-red secrets older than humanity itself. The falls flow on, unhurried, uncaring. 5 million years of quiet endurance distilled into a crimson warning that some lagoons were never meant for the living. And so our chronicle of 13 lagoons ends, not with triumph, not with hope, but with the slow, relentless drip of something ancient and hostile, finally meeting light. Nature doesn't bargain, it simply persists, beautiful and deadly in equal measure, long after we've turned away shivering. Thank you for following this descent into the planet's most unforgiving waters. If any of these places still haunt your thoughts, drop a comment. Which lagoon would you least want to face in person? Your answers keep these explorations alive.